So good morning, everybody. Welcome to the Asphalt and Transportation webinar. This is our third webinar in the Bitumen Beyond Combustion series. My name is Peter Baudouin, and I'm a senior advisor here with COSIA, and I'll be your host this morning. I'd like to first start off and give you a bit of background on the three organizations. Firstly, this is an Alberta Innovates initiative. Stantec was actually awarded the contract and undertook the study that we're going to be discussing today. And COSIA's interest in this is when we reviewed the report, we knew that this would be of interest to the innovation community, hence we are hosting today's call. So during the presentation, if you do have any questions, please enter them in the message box in the system. And our intention is to do the presentation and then have a Q&A session afterwards. We will be recording the call, and we will make the recording available online later today. I'd like to introduce you to today's speakers. First off, we have Paolo Bomben from Alberta Innovates. We also have Alex Meissen from Alberta Innovates, and then we'll be following on with Ken Harding from Stantec. In terms of agenda for today, we'll be kicking off and discussing the BBC concept as well as asphalt uses in markets. We'll then review the terminology and the production processes. We'll move on to material and transportation challenges. We'll discuss the business case, and we'll provide some insights and conclusions. And then we'll discuss a little bit about go forward in the next webinar. So today's discussion should take about 30 to 35 minutes, and as I mentioned, after the presentation, we'll be following it up with a Q&A. And on that, I'd like to hand it off to Paolo.
Thank you, Peter, and good morning, everyone. Before we begin the discussion today on asphalt, I just want to quickly go over the concept of bitumen beyond combustion for those who may be unfamiliar with it or those who may not have been present for the previous two webinars, for the first two webinars we had in this series. And to do that, and the way I'd like to convey the BBC program and the desired outcomes is to take you through a thought exercise of how you as an individual will interact with BBC products in the future. And so I want you to imagine then that you're at the office and you're leaving to go home from work, and you have about a 10-minute drive. And so you hop in your car and you start to drive home, and the first thing that you see on your left-hand side is a condo construction project. And this condo construction project is being built entirely out of wood. But it's not just any ordinary wood. That wood has actually been reinforced with carbon fibers. The carbon fibers will add rigidity and durability and length and longevity to the framing and to the project itself. The carbon fibers that have been introduced into the wood have been made from a bitumen source. And so this would be the first interaction you have on your drive home with a bitumen beyond combustion product. As you continue to drive, you notice that the road is in really good shape and it hasn't been repaved in a very long period of time. And that's because the asphalt is sourced from bitumen. And so that bitumen sourced asphalt lasts longer, provides more longevity to the road, and that's why you're not noticing any repaving being done on it. And so that's your second interaction with a bitumen beyond combustion product. A couple more minutes into your drive, on the left-hand side, you notice that there's some wind turbines. And at the bottom of those wind turbines are banks of batteries, which are storing the energy for use when the wind isn't blowing. Those batteries are vanadium redox flow batteries. And the vanadium that's critical to the function of those batteries has been extracted from bitumen. And so that's your third encounter on your drive home with a bitumen beyond combustion product. And your final encounter is as you're finishing off your drive, almost home, you're sipping on your iced cappuccino or your latte through a biodegradable straw. The biodegradable straw, the constituents that make up that straw, have origins in bitumen. And so that's then your fourth interaction with a bitumen beyond combustion product in your 10-minute drive home from work. And so I share this with you as an example of what, how you might interact with bitumen beyond combustion products in the future, examples of how they can enhance our lives and continue to provide value to everyone's lives. And so this really is the vision, this is the dream, and this is what we're hoping the outcomes of this program will lead to. To bring it back to today's topic and today's discussion on asphalt, I would like to begin by discussing the uses of asphalt and the markets of where asphalt is used. So asphalt is truly a global commodity, and it is a product that you will recognize its use no matter where you go around the world. The primary use for asphalt, unsurprisingly, is for roads. Almost 80% of all asphalt is used for roadway and roadway construction. Beyond that, some smaller uses, but the primary use that remains is for waterproofing. Water can be very, very damaging, and so asphalt is a great barrier for water, and so it's used on our homes and in roofing tiles, roofing felt, sealant around the base of our homes for our basements to prevent water from coming in. Roughly 15% of asphalt use is for that purpose. And then finally, some more niche uses to round it all out. Greenway trails, various sports courts make up the balance. And so there's great use of asphalt for our everyday lives. There's also great consumption of asphalt on an annual basis. In 2016, roughly 123 million tons of asphalt were used around the world. The majority of that in the Americas, although the Asia Pacific and European and Middle Eastern and African markets were not too far behind. And that is expected to grow to roughly 150 million tons by 2021 at a growth rate of roughly 4.1%. Now, how big is 123 million tons? Well, that is roughly 3.6 million, if all of that were to be supplied by bitumen, it'd be roughly 3.6 million barrels per day of bitumen, which is larger than the current output of bitumen from the province of Alberta. So it is a significant amount of bitumen that we're talking about, a significant amount of asphalt, and also represents a significant opportunity if bitumen producers could access even a small portion of that market with bitumen from Alberta. And so the major suppliers of bitumen around the world include BP, ExxonMobil, Imperial Oil, and Shell. But there are a lot of regional suppliers as well, such as Husky in Western Canada. And so really what I hope to take away from this slide is that there are a lot of uses for asphalt. Asphalt is an important global commodity, and its use is continuing to grow. And that it will be a very important commodity going forward for the world and the world's needs. And so with that, I'd like to pass it to Axel, who will speak to the terminology, production, of asphalt.
Thank you, Paolo. Before I speak about asphalt production, let me define a few terms so that we have clarity. The term asphalt pavement is a colloquial term, and it's actually better to speak about asphalt concrete, because the asphalt pavement is a combination of an asphalt binder and aggregate. The aggregate may be a coarse gravel or sand or crushed rock. And it's that combination that constitutes the asphalt concrete. The asphalt binder, that is the material that keeps the other constituents in the aggregate together, is a sticky, viscous, dark brown or black material, and it consists of high molecular weight hydrocarbons, and the major constituents are asphaltenes and maltenes, with the asphaltenes representing between 5 and 25%. It's also important to note that the hydrocarbons in the asphalt binder have functional groups containing oxygen, nitrogen, sulfur, and some of them have metals in them as well. And they give the asphalt binder its sticky properties and its good mechanical properties. I should say that in North America, we speak about asphalt binders, whereas in Europe and some other parts of the world, a reference is made to bitumen. When we speak about bitumen, we talk about a constituent of the oil sands. We're not talking about a constituent in the asphalt pavement on the asphalt concrete. So a few more words about terminology by taking a look at a road and taking a cross-section or a cutaway of the road. So a road consists of several layers or courses, and the surface course, which is the one that you see, consists primarily of the asphalt binder and relatively fine aggregate. The course that underlies it, or the layer that underlies it, is a coarser aggregate with an asphalt binder typically. And the subbase course may also have an asphalt binder or an asphalt emulsion in it. And the subgrade is just the natural soil that's normally compacted. This is the final slide on terminology. Oil sands bitumen is the hydrocarbon constituent that is found in the Alberta oil sands. It's a viscous black material consisting of high molecular weight hydrocarbons, and its primary constituents are saturates, aromatics, resins, and asphaltenes. They're abbreviated as SARA compositions, and you see some numbers here on the right-hand side. And the final point I'd like to make is that there are additives to asphalt. They may be polymeric materials, or they may be inorganic materials to give the asphalt binder its very special properties. Now let me turn over to asphalt binder production. If we have a conventional crude oil as our feed material, we subject the conventional crude oil to two types of distillations, atmospheric and vacuum distillation. And the short residue, which is the heavy ends, are essentially an asphaltic material, an asphalt binder material. They're often subject to some other treatments, such as air blowing, before they go to storage and then to market. If we produce the asphalt binder from oil sands bitumen, the process can be very similar: two distillations, followed by air blowing and storage, and then going to market. However, in the case of oil sands bitumen, there's a larger percentage of heavy materials that end up in the asphaltic section than in light crude petroleum. This slide is slightly different insofar that it doesn't aim at producing an asphalt binder, but that it produces an asphaltene section. And it's important to note that because asphaltenes are a useful additive to asphalt binders. How do you make asphaltenes? Well, and if you start with bitumen, you can do the double distillation, and then you subject the short residue, which is the bottom of the vacuum distillation, to a solvent fractionation. Or you can start with raw bitumen and subject it to solvent fractionation using heptane or pentane or propane, and that results in you obtaining the asphaltenes and some other cuts, which can then go to market. I'd like to turn it over to Ken to speak about the material challenges of asphalt binders.
Hi, thank you, Axel, and good morning all. Asphalt binder is not a static material in its everyday application. It does undergo change due to the physical and chemical environments in which it finds itself. And this impacts the nature of the binding, the adhesion between the binder itself and the aggregate. And typically, how do we see this in our everyday life? We see it in the form of potholes, the image on the right-hand side, and then rutting, these elongated cracks. And one of the questions we would like to pose for this innovation forum, as it were, is the key questions. Is oil sands bitumen a suitable feed for a high-performance asphalt binder and/or asphalt emulsions? Looking at the transportability of asphalt binders, one of the key challenges that we face is the nature of the material. It needs to be transported in a hot molten form, and typically this is by tanker on the left-hand side, top left, and rail car on the bottom left. Increasingly, we have seen that molten asphalt binder is transported by ship on the top right-hand side, and there's a link that we've got on the bottom right-hand corner that you can reference for yourselves. But obviously transporting material over great distance as opposed to just serving the domestic market does carry safety and logistical concerns. It is not easy to do, and likewise there is an associated cost. The desired end result that we'd like to pose here is it would really be great if there was a solid, free-flowing, non-clumping pellet that we could manufacture that would be compatible with current bulk transportation systems where this operates at ambient temperatures. If you eliminate the 150-degree requirement and you are able to use rail cars, bottom left, and the existing infrastructure that you see on the right-hand side at bulk handling terminal facilities, this would be a great asset to have. In short, a large-scale pelletization technology of some manner of form is required. If one looks for industry parallels, and this we found during the work that we did for the BBC Two report, is we found there are industry parallels, albeit reasonably small at this stage. The first example is Nitec Corporation based in Vermont in the USA. It is a pelletized asphalt binder, and this is an existing commercial product that is sold into the market. What they have is they have an asphalt binder that they coat with a polymeric material and then follow that up with a mineral coat, as you can see on the right-hand side. And the mineral coat obviously keeps this asphalt binder in a free-flowing mechanism where it can be taken into road construction. The second example that we have is closer to home. The developer of this technology, Canapux, is by Canadian National Railway, and they have announced a pilot program for the demonstration of this technology, and you can find it at the link supplied on the right-hand side. And just for the audience that aren't familiar with the terminology Canapux, well, just imagine a yogurt cup, as it were, if you will, with a bitumen-like material inside that yogurt cup and sealed. This has the advantage that it's no longer sticky. You can use bulk handling materials to move the puck around, and an added feature that the video does demonstrate is it is floatable as well. So from a safety and handling and pollution perspective, there's certainly some good advantages to be had of this technology. So if we could develop something along similar lines, as those two examples have been shown, it would be very beneficial to the industry. In terms of the business case for asphalt binders and transportation, during the study, we had a look at various aspects that's happening in the global asphalt binder market, and clearly there is demand due to economic development and the increasing road density in third world and developing countries. One can imagine that the North American, European markets have a high road density, and those features will roll out into developing economies. It is a growing commodity globally, that is for asphalt. There are certain environmental aspects as well that asphalt brings. It locks in carbon permanently, and it is 90% recyclable, and it has wide social acceptance. Asphalt has been around for a very long period of time, and it is commonly seen in our environment. It is an exciting market that is growing. In 2016, the market was approximately 126 million tons per annum, as Paolo indicated, and around at a 4% annual growth rate by 2030, we expect the market to hit 200 million tons per annum. Looking at the business opportunity specifically, when we did the study, we identified a couple of asphalt binder prices in the international market. And as you can see, for China, Japan, and South Korea, these prices are reasonably high, ranging from the 540 Canadian dollars per ton closer to $1,000 per ton for South Korea. The production cost for a binder material in Alberta, we believe, would lie roughly in the order of 150 Canadian dollars per ton, and if delivered to Shanghai, could fetch a price of 430 or more correctly, I should say, that is a price we believe one could supply asphalt into that market, and it would be very beneficial if one can look at that margin as shown by the previous examples. And with that, I'd like to hand back to Paolo.
Thank you, Ken, and thank you, Axel, for taking us through a discussion this morning on the production, transport challenges, opportunities, and business case for asphalt from oil sands bitumen. So I'd like to now bring it back together and summarize the presentation through some insights and conclusions. I think the overarching consideration in all of this is that the world is changing, the world is growing from roughly 7.8 billion people today to 9 billion people by 2050. And with the growing population, there will be a growing demand for goods, vehicles, transport options, and the requirements for those transport options will undoubtedly require asphalt. And so that is also played out, as you've seen to the previous slides, in the growing demand for asphalt globally, significant growth expected over the coming years and decade. And so with that changing world, with that growing demand, the other consideration is the need to find diverse markets for our bitumen product here in Alberta. And so the opportunity now to utilize bitumen for asphalt to meet a growing global demand is a significant opportunity. And we can take advantage of that opportunity because of the competitive advantage that bitumen offers. Namely, that it is a lower cost primary feedstock for asphalt, that the actual process of producing asphalt from bitumen is not unlike the current processes, conventional processes for producing asphalt. So in terms of the know-how and the ways to get there, it's very well understood, the process. And so that also leads to lower costs and a competitive advantage for us. Of course, to actually unlock all of this, we need to confirm that asphalt from bitumen is of a higher quality. And of course, the transportation element is very important. Finding a solid form shipment option would unlock markets globally around the world and would reduce any restrictions required by the heating and molten requirement that is currently needed to transport asphalt. Of course, one of the great advantages of asphalt is, of course, its recyclability and its use and the ability to trap carbon into the product, as Ken mentioned. And so that's another key consideration, that social acceptance for asphalt is very well understood. It's high, and in terms of potential concerns in that respect, there shouldn't be really any. And so, these are the key points, these are the key insights that I hope we've convinced you of and you'll be able to take away. I also want to mention that in terms of all the different BBC products I mentioned at the beginning, from carbon fibers to vanadium, for vanadium flow battery use, to polymers, asphalt is the most mature of those four. It is the closest to market. It is the near-term option in terms of BBC products. So that wraps up the formal part of the asphalt discussion, but I want to come back to the question of potential higher quality, because that really is important. And I want to use that as a segue to talk about the funded projects from Alberta Innovates from our BBC open call, because that question around higher quality will be explored by the first two projects that I show here on the screen, by Dr. Simon Hesp at Queen's and Dr. Leila Hashemian at the University of Alberta. Respectively, these two researchers and their teams will explore the use of bitumen-based asphalt in the top course and the base course on the roadway. And they'll be benchmarking that against existing asphalt options from other suppliers. So by the time these studies wrap up in 2 years, we should have a really good understanding and a really good sense of just how well asphalt from bitumen stacks up against the current market. And it's our hope and expectation that it will be very positive, which will then further enhance the business case and the market case for using asphalt from bitumen, not only domestically, but globally. And so those are the two key ones that are linked to asphalt out of the 7. The other 5 are related to our other BBC focus areas. So Dr. Chen from the University of Alberta will be exploring the fabrication of short carbon fibers using asphaltenes. Dr. Gupta from the University of Victoria will be exploring the use of carbon fibers to enhance the properties of cement to make it crack-free, and as also to enhance the properties of asphaltic concrete. For those of you who attended the previous webinar, you may remember that we discussed combination products and how carbon fibers can enhance existing products such as concrete or wood through their incorporation. And so Dr. Gupta will be looking at that from the concrete side. Dr. Chen at CanMet in Devon will be exploring the production of nanostructured materials from coke, which is a significant product from bitumen. Dr. Lee at the U of A will be looking at the production of graphene-like materials from asphaltenes. Graphenes are a very important and emerging component in electronics, and the expectation is that they will become much increasingly prominent as the years go forward in the electronics industry. So that's what Dr. Lee will be exploring. And finally, Dr. Musalek at the University of Alberta will be looking at vanadium redox flow batteries and their use in Alberta in our harsh environmental conditions, from our hot summers to our cold winters. How do these batteries stack up as potential energy storage vehicle for devices for renewable energy systems in the province? And that is the end use case for extracting vanadium out of the asphaltenes fraction of bitumen. And so these are the first 7 that we have selected for funding. This is by no means the end of Alberta Innovate's interest in funding projects for technical advancement in the BBC focus areas. We continue to be open to ideas and projects that will further the technical gaps and market gaps within the BBC focus areas. So we encourage you to reach out if you do have ideas that can help further the BBC areas along. The one thing that those of you who are familiar with the BBC program might note that there are some gaps in the project. So for example, there are no projects related to polymers. And so that is an area that we continue to explore. And in fact, that's a great segue to my final slide, which is to plug our next webinar, our final webinar in the series on polymers, which takes place on February 28th from 10 to 11 a.m. Mountain Time. This webinar will focus on a few key areas. So we'll talk about biodegradable, compostable polymers, why they're important, why they have been selected as sort of the focus area for BBC. Bitumen as a polymer feedstock. This is one that some people may not be familiar with, so we'll explore that idea and also address some of the significant technical challenges as well as open questions that remain in terms of making polymers from bitumen and how this will take a broad effort from the community at large to help bring polymers from bitumen to market. And so we hope you can join us. Our registration is now open on the COSIA website, and we look forward to seeing you in February for that webinar. And for now, I'm going to pass it back to Peter to wrap us up.
Okay, well, thanks everybody. That concludes the presentation part of today's discussion. We would now like to open it up to questions to the floor. For those of you who do have questions, please enter them in the message box. They'll come up and we will, take some time. We do have, 30 minutes to go through this, so please submit your questions. And on that, has there been some questions come in? Yeah.
All right, I'll start here. Could we differentiate oil sands derived asphalt from other asphalts, i.e. breakout of commodity markets?
Do you want me to answer it? Anyone else? The answer is potentially yes. And why am I saying it? I'm saying it because oil sands are very rich in the primary constituent of high quality asphalt, namely asphaltenes. However, to make really high performance asphalt is not just a question of asphaltenes, but it's also a question of the other constituents. that may be present. Waxes have often been cited as being a problem. In other cases, they've been cited as being an advantage. And that is one of the things that we are exploring. Certainly, there is a good record of using oil sands bitumen as an asphaltic feedstock, but to arrive at the really high quality that one is looking for so that roads don't rut and they don't crack, that remains a challenge to be explored.
Great.
Maybe I can just add there further is typically when you look at the asphalts from a chemical perspective, they are by nature the material very challenging to analyze, and typically they've been applied and characterized at a gross chemical level or performance mechanical level. And I think advances in analytical techniques are certainly presenting an opportunity to get a deeper understanding of the characteristics of the material. And most certainly, I think if one looks at the 2 projects on Paolo's list that have been awarded, that is part and parcel what it is about, to get a deeper understanding at a chemical level, not only in the mechanical level, of how asphaltenes or asphalt binder derived from Alberta could have higher performance, and hopefully that will prove the case.
Great, thank you.
The asphalt market has a seasonality to it here in North America. Is that true in the offshore markets, i.e., would there be a year-end market for potential product?
The answer is yes on both counts. In North America, it is definitely seasonal. This is partly because practices to build and reconstruct asphalt roads during the winter months is challenging. But it also complicates the transportation of the asphalt binder, because as you will remember from what Ken said, the binders are transported at about 150 degrees, and if they are transported in railroad cars and sit on a railway siding for a week or so in our current weather, they will end up as solid. So they have to be steamed out, and this is both costly and problematic. So if we could ship asphalt binders in appropriate solid form to overseas market, it would reduce the seasonality of the demand, which would make it much more efficient to run our asphalt production facilities here in Alberta.
In our preliminary look at using oil sands bitumen for asphalt, the tests indicate that additional processing is required beyond what is required for traditional asphalt sources. Does that mean we would have potentially a byproduct or a waste?
I'm reflecting on that question. Thank you for the question. It's a great question, and might I suggest that whoever sent it, we also take that question offline. From a personal perspective, I like to see things through at a chemical level and get an understanding. I think the short answer to this is a yes and a no. Is yes, additional processing is required, and that always raises a question of what is the cost. But then you've got to understand why you're processing and what modification it brings to the material and what value add that modification potentially brings. So that's the short answer. It's not a no that it doesn't bring any advantage in terms of the marketing, but further investigation would be required, and I'd encourage you to reach out and we can have that conversation.
Mm-hmm. If I could just add to it, if that additional processing results in an other waste product, that's a serious issue because the waste product has to go somewhere. And one of the advantages of not having a waste product in connection with asphalt is just that the carbon is stored there and it can be used in that fashion. So every effort should be made not to have a waste product. If there's a byproduct, then the question arises, is that a useful byproduct, or does it have to end up in a landfill? And that's not what we want to see.
Is the technology to develop solid pellets needed to make asphalt derived from bitumen economical, or is it more to ease shipment bottlenecks?
Is it economical? Well, the work needs to be done. That question is unknown in terms of is it economical? And obviously one has to reflect at what scale it is done and done at in the particular market that you're focusing at. Consideration of the NITEC company hasn't lent too much information other than what's available on the website. We are aware that the company is selling technology or has developed its own technology for pelletization. And you'll be aware of in the report there's another company in the UK called Roadmender that is doing a form of pelletization as well. It does depend on the market and the application, as well as the actual nature of that transformation from a molten state to a solid state, and obviously the scale at which you do it. And this is part of the proposal. And I think this is what Paolo's trying to encourage from Alberta Innovate side, is getting responses back from the innovation community and to work hand in hand in a collaborative fashion.
If I may just add to it, it is more than just pelletizing asphalt, because if you just produce a nice asphalt pellet, the pellet will be sticky under certain conditions, particularly in hot tropical environments, and that's something that you cannot tolerate. It has to end up being free-flowing. That's why people have made efforts to envelop the pellets in some material, and the NITEC schematic shows that. So pelletization by itself is not sufficient. Something else has to be done. And there's some interesting ideas, and we invite other interesting ideas to come to the forefront.
Lots of research has been done in the Department of Civil Engineering at the University of Calgary, Husky Endowed Chair in Bitumen Materials. What has been your criteria to involve university research groups?
Well, the primary criterion is that we, after inviting applications, and we've certainly invited applications from all universities in Alberta and even beyond, the primary criterion is then to look at the proposals that we receive and to judge them by the criteria that we use internally within Alberta Innovate, which means proposals have to be scientific, technically sound. It means that proposals have to address an issue on a scale that is meaningful. For the BBC Open Call, we had a requirement that for the industry as a whole, there should be a potential of utilizing 100,000 barrels of bitumen per day. And certainly anything that's related to road asphalt would meet that criterion. But we need some innovative ideas to deal with asphalts that are derived, asphalt binders that are derived from bitumen. And we welcome more.
For the NITEC Corp pellets, do the polymer and mineral coatings affect quality? What minerals are used for the outer coating?
Okay, as far as I know, they're only described as clays, and I have no further information on what they are. It's not unusual to add clays to materials that are polymeric in nature and are slightly sticky. They've ranged from things like talcum powder to inorganic clays. But you'd have to ask the company, and I don't know the answer to that specific question.
As Axel indicated, the use of a mineral like lime on the outside is fairly normal, or at least for this company. If you look at their patent literature, they indicate polymeric material, and the nature of polymers that can be used as a binder or as an asphalt additive in its own right is fairly broad, and that would depend on the application and the nature of the technology itself, the physical machinery that NITEC use.
And it's clear that what one wants to achieve is that the binder contributes to the properties of the asphalt when it is being used in making a road. So you don't want to separate the film that surrounds the asphalt pellet before you can use the core of the asphalt pellet. And you can choose polymers that have those properties. And I'm sure that's exactly what Nitec has done.
Do all oil sands sites yield quality asphalt? If not, do we know which leases yield good asphalt?
I think all oil sands sites yield good quality asphalts potentially, but not all oil sands sites are identical. There's a fair variability even in terms of their SARA content and certainly in terms of their asphaltene content. And asphaltenes are not a single compound either, they are a mixture. So you have to really look at each and every one of them and see which one is more conducive given the processing that you undertake.
So that's the end of our questions. We're definitely open for more, so maybe we'll give it a minute and see if we'll get a few more in. Again, just to plug our next webinar, so it is expected on February 28th. So again, I think it is available on the meetup already, and if not, we we will be probably sending it out. Will we be sending it out again?
The invitation to the next
Yeah.
one? Yeah, certainly. We can send out the invitation to everyone who's registered for this event.
Okay. Okay. So again, we'll open it up to questions. We'll give it a minute, and if not, well, we'll close the call.
We have one that's come in.
Great.
Is there a possibility to use waste plastics such as HDPE as a polymer?
I think the question is whether one can use that waste plastic as an additive to asphalt, at least to the asphalt binder in today's context. And the answer is potentially yes. Some work has been done in that area. The trouble with waste polymers is that they are not a single polymer either. They are often associated with other polymers, and only some of them really work very well. So the uniformity of the feedstock is a major issue in that regard. But polymers of the kind that have been mentioned have been explored on a small scale basis and deserve further attention, but the problem is that most waste polymers are mixtures, and mixtures are not all the same, and that has an important bearing on asphalt quality.
Is there a time scale when we can expect shipping of pellets to global markets?
Well, if the answer is focused on shipping pellets on a very large scale, we don't really know because the pelletization process on a large scale has not been established. On a small scale, Nitec and others, Roadmender is the other company that Ken mentioned, they are shipping pellets right now. But these are small quantities, not by the thousands of tons per day types of quantities that we are looking for in order to make it meaningful as a major export opportunity for Alberta Oil Sands asphalt.
Is Alberta Innovates currently funding any bitumen solidification project?
So at the moment, we do not have any asphalt solidification projects within our bitumen beyond combustion portfolio. It is an area that is a gap. As you know, as you saw on the 7, it's not listed there. So we continue to entertain inquiries and project proposals in that area.
This is a bitumen solidification. He asked about bitumen solidification.
In terms of bitumen solidification, I am not certain if Alberta Innovates is. It may be beyond the portfolio areas that I am involved in. It is certainly not an area that we have explored within the bitumen beyond combustion area.
So can I just clarify then, Paolo? Yeah. If there are listeners who do have ideas, even in any of these areas, you are open for business. You can, please, they can get in contact with you guys to see if there's potential funding. Okay.
Absolutely.
Yeah.
Absolutely.
So no need to wait for next call, although there might be one that's not confirmed yet, but you're open for what's,
And in fact, I will mention now on the line that we do have a current open call for our Clean Technology Development Program, and bitumen beyond combustion projects are eligible for funding within that call. So, and that is an open call at the moment that closes on February 21st. So if you do have ideas, there is a current call that is open that you could apply to.
Yeah, so please look at the Alberta Innovates website, and if not, I'm sure Paolo's email is here on the screen. Please email him and he can give you more details.
All right.
Okay.
Do you have a breakdown of the market for asphalt roads? The asphalt required for airport landings and bridges matrices is a higher quality and performance, but the market volume is much lower. What do you see as the possibility to gain a market share with Alberta bitumen?
I think certainly that would be a definite goal. To answer the first question, do we have a market report? No, we currently do not. Most certainly the work of the two projects that Paolo has had on his list earlier, in terms of understanding the performance properties, the mechanical properties, the 2-year study with Dr. Simon Hespen. Paolo, if you'd just remind the other.
Dr. Leila Hashemian at the University of Alberta.
I think that would certainly go a long way to help answering that question.
Yeah, and they will shed light on the different kinds of asphalt binders and products that you can make using superpave criteria, which include performance criteria at very low temperatures, like Arctic type of temperatures, as well as high temperatures of the kind that you encounter in the tropics.
Could I just confirm, I mean, we have up on the screen now a view to the report and a link. Is there additional information available in the report that could be of benefit to answer some of these questions? Because there's additional information, correct? So
Yeah, there is. And references have been provided within the report.
Yeah.
It might not answer the immediate needs of the question posed.
But there's additional information there. Yes, I'd suggest you do have a look. It's here on the screen, but again, we can, if you just Google that, the actual bitumen beyond combustion report, you'll get a link to it.
Yeah, or you can just put in those websites, and it will come up directly.
Okay.
How are plastic polymers used to coat pellets, such as with canopucks, removed at the receiving end refinery? Does it require special processing, melted off?
I think from a practical perspective, I can't answer that question directly from first-hand experience, but if I may hazard a suggestion, is that material would be included. I think certainly from a practical perspective, that would, just be considerably easier, because why? If you try to separate the polymer, you would then have a waste material at the other side at the customer that you'd need to deal with. Again, sorry, I can't answer the question directly, and I suggest the person asking the question reach out to Canopucks and ask that question directly. And my answer was just from a practical perspective.
It should be noted that Canopucks are being developed in order to transport bitumen, not in order to transport asphalt binder. However, that technology should be quite suitable to asphalt binders. In the case of transporting asphalt binders in the form of canopucks, if you choose the polymeric material appropriately, you don't actually have to separate it when you make your hot mix asphalt, because the shell, which is the polymeric material, will melt and be dissolved in the asphalt binder. And if it has the right properties, it should enhance the quality of the asphalt binder. If you use canopucks in order to ship, in effect, bitumen, and your intention is to use the bitumen in order to make petroleum products such as gasoline, then you're faced with the separation of what to do with that polymeric shell. And there may be a market for it, or there may not be. But in the case of asphalt, these shells could potentially be incorporated into the asphalt binder that goes into the roads or whatever use.
Have you looked at Vault, a Swiss company that ships globally in containers, or colas that ship asphalt around Africa?
We are aware of Volt, and we have had a look at the company, and it was a cursory observation and not in depth. The focus on the report was not directed to in depth, for argument's sake, engaging with producers like that. It was driven from a Alberta innovation perspective.
Yeah, and I would add to it, containerized shipment of commodities such as asphalt binders or in fact bitumen is possible, but it is not suitable for the very large volumes that one is looking at. The handling problems are just excessive, which translate themselves into costs, and that becomes prohibitive in relationship to other options that the ultimate user has.
Okay, well, I think that's the end of the questions. We'll leave it for 1 minute and then close it down because it is 10 minutes. We have 20 minutes of questions, which is great. So we can usually see them queuing up. Just a reminder, this call will be recorded and we'll be putting it up on our website. Earlier, I think I said today, but it'll probably take a week before we get everything up. It usually takes us a bit of time to get that done, so perhaps I misspoke. On that, we don't see any new questions coming up. So I'd like to thank all the speakers for their time today. Thank you for joining. Please look in your inbox to see if for the next invite, and we look forward to talking to you at the February event. Thank you very much.
Thank you.
Peter.
Goodbye.
Bye-bye.